Hi guys, welcome to another video of the Raspberry Pi 4 tutorial using the Freenove Ultimate Starter Kit. So I was thinking I should give some kind of introduction if some of you guys have not seen my previous video before. I've always wanted to learn about electronic components and improve my programming skill. So a while back I did a bit of searches and reading online and finally decided to buy myself a Raspberry Pi 4 and a Freenove Ultimate Starter Kit. So this Freenove Ultimate Starter Kit here comes with tons of electronic components and a really detailed tutorial showing you how to get started on your Raspberry Pi 4. There is a detailed electronic wiring pictures provided in the tutorial to teach you how to wire up the electronic components in the circuit. Also in each chapter, you'll be able to use the code provided, which is also in the tutorial, to create your own program that works with the electronic component. So I thought to myself that it would be more fun recording and going through the individual chapters and learn about the programming and the basic of electronic component. Well, that's the main gist of it, and now let's get started to the next chapter. So in the previous chapter, I only got to try out the single LED, and by using a switch, I was able to turn on and turn off the LED with the help of some programming. But for this chapter, which is called LED bar graph, a new component is introduced, which is this rectangular component here that has 10 LED integrated into it. So if you look at it, every single white bar here represents a single LED. So in total, there is 10 LED integrated into this one electronic component. So this particular project is not just about turning on and turn off the LED. Well, you still do turn on and off the LED, but you use the coding to make the LED looks like it's actually moving. So the component needed in this project are basically the LED bar graph, a bunch of jumper wires, and 10 of this 220 ohm resistor. So before starting on the wiring, I noticed that the wiring for the LED is different from the previous chapter. Previously, we used the individual channel as an output and used a jumper wire to connect the output to the resistor and back to the ground. But for this project, we actually used the constant 3.3 volt channel and wire the other end to the individual channel. After going through the coding, I was even more confused as I realized to turn on the LED, I have to set the output channel to low, which is a bit counterintuitive if you base on the previous chapter, which is to turn the LED on, you have to set the output to high. But in this case, it is low. So, but if you look at it through the point of water flowing through a certain height, it kind of makes sense. So I'll draw it out to make it easier to understand. So if you look at it through the point where electricity is like a flow of water and the voltage is the height. So when our 3.3 volt channel will be like on a height of 3.3 meters and our jumper wires would be like a pipe. And if we assume the other end is connected back to the channel, which is GPIO 17 as an example here. So if we set it to high, which is the same height, 3.3 meters, 3.3 volt in this example, water does not flow because it is at the same height. But when we turn GPIO 17 to low, the height actually goes to 0. And with our main channel 3.3 volt still holding on to the same height, water starts to flow through. I will draw the pipe here. Pardon my drawing. And this at this moment, when we set GPIO to 17 to low, water actually flows, which means electricity starts to flow. And with electricity flowing, our LED here will light up. Well, basically that's how I would look at it in my way. So let's put this back to here. And with that out of the way, we can actually start the wiring for this particular project. So I'll now start the wiring for this particular project. Let me just get the wiring of the breadboard so you will be able to see it. And we can start off with the wiring. So the first thing we're going to do is to start to have the 3.3 volt here. Well, we use a shorter wire and we'll connect it to the positive, which means the 3.3 volt we actually send the current all through this particular row, and we'll go straight to connect the bar graph here. And next will be our resistor, 10 of our 220 ohm resistor. That's a lot of resistor. So all of them will have the main connection from the positive to the LED. Oh, the breadboard is really small, and with so many LED, I hope they don't touch each other. Alright, and with that we are done with the 10 resistor. So next we'll need to wire the other end back to our individual channel. So for that we will need this. All right. And finally, the last one will be CE0, just below GPIO 25. And with that, we are done with the wiring. Alright, well, the resistor looks a bit messy here, but I guess it will do. So, and with that, we are done with the wiring. We shall now proceed to the programming. So first, we need to power up the Raspberry Pi. Alright, the Raspberry Pi will need to be connected first. Alright, our Raspberry Pi is powered up. And let me just adjust the screen here. Move it back to the top right. Alright. And we shall now wait for the Raspberry Pi to connect, to power up. Alright, our Raspberry Pi is up and running and we are ready to start decoding. So to start it off, we need to open this Tony Python IDE program. And once it's open, we are ready to start. So for the first line of code, we'll be importing in this library of code, which is called rpi.gpio. You can find information of this library in the tutorial. This is basically a library of code that we need to import into this program to allow Python to use the GPIO board function. So import rpi.gpio as GPIO. So in the next line, we'll be importing in another library, which is called time. The reason we are importing in this library is because we will be using a function in this library called sleep. So this sleep function will give us the ability to put some kind of delay to our code. It's like to hold something for a particular second, or how much time that you give it. So which is import time. So that is the two library that we will be using in this program. Next, we'll need to define our channels. We need to tell the Python program which channel we will be using for individual LED. Rather than creating a single name for every channel, we use this square bracket, which is called list in Python. List, like L-I-S-T. These are like a big box with many small containers for you to store your stuff. So we'll put all our channel number into this list called LED pins. The numbering here is important, as the later part of the code will go through this channel according to how we list them in order. So the name of the list will be LED pins, and the number will be 11, the channel 11, 12, 13, 15, 16, 18, 22, 3, 5, 24. So, oops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 channels. Channel 11, 12, 13, 15, 16, 18, 22, 3, 5, and channel 24. Alright, that is all the channel there is. Next, we'll need to set up the GPIO board. We'll be using this block of function, which we will name it setup. And in this setup function, the first thing we'll need to do is to tell the GPIO board what numbering to use. So let's first define the block of code, which is called setup. And the block of code will start with gpio.setMode. And the mode we choose is gpio.board. Okay, so the next setup we will do for the GPIO board is to set up the channel, the individual channel, to be an output, because you want to be sending output to the individual channel. So for that, you will use gpio.setup, and since we have listed all as LED pins, we just need to say LED pins, and they will be all out. So, gpio.out, and we are done. And the next one, which is the last one for this setup, will be the default setting for the individual channel. So to do that, we'll use gpio.output. All the LED pins will be default high, like we explained earlier. The default will be high, which is the LED should be off. And with that, we are done with setting up the board. And our next block of code will be called loop. So this is the main part where the LED perform the moving action. The first statement, before we go to the first statement, let's name the block of code loop. And the first statement, which is, we'll be using this while true statement. So this while loop is a common loop which you use when you want to perform something over and over again. So which is while true, and the next line will be the block of code that you want it to perform over and over again. So for the next line of code will be a for loop code. So for this for loop, this is a loop which is commonly used when you want to iterate a sequence. So in our case, we want our program to perform a set of action through the sequence of channel we have defined in the LED pin, which is why the numbering is important in the beginning. So to make this part of the code easier to understand, we'll run the for loop in a separate program to see how it works by itself. So we'll just open another window. So in this case, we'll just give the same same LED pins and give them a list. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll start to use the for loop. So for this time around, we just use X in LED pins, print, which is to show X. And from here, you can see how the for loop function. We'll run this program, save it as a test for loop. So if you see here, what happens is when we run the for loop, every single time the loops so-called activate, it will print X. So for the first round, it will print X, which is 1, and it will iterate down the sequence, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you just change the number here, so that just to make sure that it does run through the sequence, and you'll notice it's 1, 2, 3, 4, 10, 6, 7, 8, 9, 10. So that's an additional function which there's an additional variable you can put in to allow the code to run in the other direction, which will be used later in the program, which is this. We just need to add LED pins and 2 semicolon and add a -1 here. And you can see now it runs the other way around, which is 9, 8, 7, 6, 10, 4, 3, 2, 1. Alright, so that's how the for loop function, and we can actually goes back to doing what the project wants us to do. So for the first line, it will be for pin in LED pins. We will send a output through the GPIO pin channel. This output pins, and we'll make it low, so that would turn our LED light up. And this is where these delay functions come in, which is time.sleep, and we'll give it a 0.1 second delay. And next we will need to turn off. And next we will need to turn off. We'll need to turn off the GPIO. Giving it a high. And next, and we are done. So basically what it does is, the first round, channel 11 is activated. It will turn channel 11 to low, which is to light it up, and delay for 0.1 second, and next it will turn the LED on again. So this is one round, and the next round, and the next block of code actually, what we'll do is we will have to make the LED light go the other way around, which is what I've shown earlier. It's the same function, it's the same code, but now we will add a -1 here, which should now change the sequence from 24 all the way to 11. So the code is the same. It will be output pins GPIO.low and a delay of 0.1 second, and turn it off. And we are done with the main part of the program. Now it's the setting up of the rest of the program, which is the standard throughout. We will need to define this block of code called destroy. So what this does is it will clean up the GPIO And next is the main, kind of like the main part of the program. So underscore name is equals to main and try print program is starting. Alright, and run the setup block of code, and then to the main part of our program, which is loop. And next, we'll need a way for the program to exit itself. So, which is this keyboard interrupt. And when we exit the program, we will need to activate this destroy function, so to clean up the GPIO. And with that, we are done with the program. So let's save the program and call it bar LED bar graph. Okay, so with this save, let's see, we should minimize our code and bring our breadboard to the center stage. All right, and run the program. We have some errors. What is it? What did I miss out? For pin in LED pins. Oh my god. Alright, let's save and run again. Oh, we have, oh, all right, let's do it again. Let's clean it up and we shall run again. Now it should work, right? Yep. All right. All right. Well, as usual, one single S caused quite a bit of problem here. So basically, that's it. We have our LED running in a sequence. So basically, this is what the program is doing. So when the loop is actually activated, it will turn off and it will turn on the first channel, and you'll move to second channel. The timing is definitely faster, 0.1 second, and you just go up and down, down and up, down and up, down and up. Well, we are done with the program. I hope you guys liked the video, and if you like it, please do subscribe and like and share.